Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the introduction to definite integrals. But recall, this is part 5. So if you've missed out on all the other parts prior to this, I encourage you to go over them, for they carry a lot of insight. Let's dive into definite integrals. So integrals of the form integral from a to b of f of x dx would then be integrated to give us a capital letter f of x that has to be evaluated from a to b, so that we have capital letter f of b minus capital letter of a, where in this case a is the lower limit and b is the upper limit. So a and b are elements of real numbers, and a is less than b. So these are also known as definite integrals. So every integral of this form is known as a definite integral because they consist of limits. So take note, the constant of integration is excluded because we are evaluating at a and b. So the capital letter f of x is the integral of the small letter of x as indicated in the integration video part 4, and I encourage you to go over it. So now, the rule of integration highlighted in integration video part 1 are all still applicable. In addition, we also have integration from a to b of f of x is equal to the negative of the integration from b to a of f of x dx. That is to say, we are going to find a value that would be negative of the interchanged a and b values. And also, if we are going to integrate from a to b of f of x, and there happens to be another limit that is in between a and b, say c for instance, then we are going to have integral of a to c of f of x plus c to b. So it's important to take note that c is between a and b, and a, c, b are all real numbers. Now, let's dive into example 1. Example 1, we are asked to evaluate the integral from 0 to 2 of 4x cubed minus 2x dx. So the solution, we would go about it by integrating the usual way. So recall from previous videos, when we are integrating, the power changes and we divide by the new power, so that we get x to the power 4 minus x squared. So we still have 0 to 2. Now we are going to evaluate or substitute for the limits, starting with the greater one, so the 2. Where we have x, we are just substituting by the 2 in the first square parenthesis, and we subtract what we have as the lower limit in the function that we have. So in this case, we're going to have 2 to the power 4 minus 2 squared, all minus 0 to the power 4 minus 0 to the power 2. So we can evaluate this individually, and we are going to get 16 minus 4 minus 0, which ends up as a 12. Great. So now let's dive into example 2. So with example 2, we have evaluate from 2 to 3 of 3 minus 6 over x cubed dx. So as usual, we would apply the laws of indices, recall from our previous videos, so that we have the integral from 2 to 3 of 3 minus 6x to the power minus 3 dx. And integrating that, we would get 3x minus 6 over 2, x to the power minus 2. So let's keep the limits outside for now, so that we have 3x plus 3x to the power minus 2 having our limits. So the next step is to substitute for x with our limits, starting with the upper limit, which is a 3 in this case. So in doing so, we are going to have 3 times 3 plus 3 times 3 to the power minus 2, all subtracted with 3 times 2 plus 3 times 2 to the power minus 2. Now, evaluating those ones individually, we would get 9 plus 1 over 3 minus 6 plus 3 over 4, which ends up as 2 and 7 over 12. Now, so take note, this is how we would go about substituting for these x terms, and this is known as the definite integration. Let's take a look at example 3. So example 3, we are integrating from minus 1 to 1 of 8 over x minus 2 squared. So as usual, we would deal with the denominator. We use the laws of indices so that we have 8 times x minus 2 to the power minus 2. Then we go on to integrate. So as we are integrating, recall from our past video, and that was part 3 and part 4, where we looked at such kind of expressions. So when we apply that, we are going to get 8 times minus x minus 2 to the power minus 1 and still keep the limits. Right, so the next step is to simplify that before we apply the substitution for the limits. So we can take out the negative so that we have negative 8 outside. Then we substitute with our limits. And recall, we start with the upper limits. So as we do so, we are going to have minus 8 multiplying everything in the curved parentheses so that we have 1 minus 2 to the power minus 1, then minus 1 minus 2 to the power minus 1. So in doing so, simplifying, we are going to end up with 16 over 3 is our final answer. And of course, that simplified, we are going to get 5 and 1 over 3. Great, so now let's dive into example 4. So with example 4, we have given that y is equals to the square root of x plus 1 raised to the power 5 divided by 10. We are meant to find the dy dx. And recall, this is something we covered in our video, part 5 in integration. And I encourage you to go over that because that would help you. Then we also covered questions where we had to deal with the hence evaluate. But this time around, we've got our limits because we're dealing with the definite integration. Right, so the first part is to make sure that we recognize what our n is so that when we differentiate this, we are able to do so without any hassles. So our n is 5, and the integral of what is inside the parentheses there is x squared plus 1. So differentiating that would give us 1 over 2 times x to the power minus half. And of course, we knew our n to be 5, so we just multiply it. Then we reduce the power by 1. So reducing 5 by 1, we get 4. And in so doing, we also simplify, applying the laws of indices. We would end up having our answer as that given there. Great. Moving on to B. So with B, recall, what we are doing here is just reversing what we have obtained in A, because we know that there is a direct relationship between A and B. So we are saying we're just moving from what we have from A, going back to what we must get in B, which was the question itself that we were given. Right, so with that, we want to express the B part in the form of what is the answer in A. So recall, in A, in the denominator, we had a 4. But now, in the expression that we are meant to integrate, we don't have the 4 in the denominator. So we would introduce a 1 that comprises of 4s. So we are saying that 4 divided by 4 would give us a 1, so that we can take out the 4 in the numerator outside of the integration function and multiply with the divisor, which is a 4 in this case, so that we end up having something similar to what we obtained in A. So because we have something that is identical to what we obtained in A, we can safely say that that is going to be 4 over 10 times square root of x plus 1 raised to the power 5, because that was the reverse of what we obtained there. So if this seems to be confusing, please check out our part 3 and part 4 videos, for we cover such topics. Now that we have this, we are going to substitute the upper limit and the lower limit. So recall, we start with the upper limit, subtracting with the lower limit. So in this case, we are going to have that, and then simplifying that, we end up having 4 over 10 times 3 to the power 5 minus 2 to the power 5. And that would simplify to 84, and 2 over 5 is our final answer. If you've made it thus far, great job. Congratulations. I'll leave you with the following task. Thank you so much for watching Numbers Simplified. Remember, your feedback is always welcome here. Subscribe, like, and share the video. God